What's up, everybody? Mr. Babbitt going to make a online notes video here for you. 14.1, we're getting into the unit circle. And what this is a mixture of both degrees and radians. And this is kind of what I talked to you about, how we can better memorize what's going on. We don't have to work quite as hard. So where this kind of comes from is special right triangles. So we have this one up here. We'll say that this little corner angle is 30. We got 90 down there, which means that this is 60. And we know across from the 30 is 1/2. Across from your right angle is going to be 1. And then across from the 60 is √3/2. And this is going to stay the case as we move forward. We got a 45, 45, 90 triangle here. And the hypotenuse would be 1. And then both of these would be square root of 2/2. Same thing right here as the first problem, except for now this is the 60, this is the 30. Across from the 30, 1/2. Hypotenuse always 1, which makes this √3/2. So depending on where the 60 and the 30 are, the triangle might look a little different, but 1/2 is always across from the 30, and √3/2 is always across from the 60. So when we get down to this problem, it says label the degrees. We've been doing this, we're comfortable with this, so I won't take too long. 0, 90, 180 here, and then 360, or sorry, 270 down here, and then 360 is all the way around. We know halfway between 0 and 90 would be 45. Halfway between 90 and 180 would be 135, because we're adding 45 to get there. If you add 45 right here, is going to give you 225, and then adding 45 again gives you 315. What we know is that our unit circle, we're going to have 3 different angles between 0 and 90. We're going to have 30, 45, and 60, and it's always going to go in that order. So to get from 90 right here to our next angle, we would just add 30, so this would be 120, and then to get from here to our other one over here, you would add 60 degrees, which would make this 150. So you can see that our reference angle right here is 30 away, just like it is over here on this side. So that stays consistent. As we keep going, we add 30, you get 210 right here. You add 60 to that, you get 240, and you can see it is 30 away from 270. 300 goes there, and then 330 goes there. So these are the degrees of the unit circle. We have a pretty good understanding of why that is so far. And then if we go over here to radians in the last unit, we weren't as strict on using radians, but we're going to have to get into it now. So this is 0, and we said that halfway across the circle over here is going to be pi. So halfway between 0 and pi would be 1/2 of the pi, or pi/2, like that. We also said that all the way around is 2 pi, right? If we go all the way around, so right here would be 1.5, and the way that we write 1.5 would be 3 pi/2, because 3 divided by 2 gives us 1/2. As we go through here, what we need to know is that pi/6 is equal to 30 degrees. We have pi/4 is equal to 45 degrees. And then pi/3 is equal to 60 degrees. So we know that this first little angle is 30 degrees. But when we're doing it in radians, that's going to be pi/6. Pi/6. And you can think about it the way we split it up before, right? This would be 1, 2, 3, 4, 5, and then 6. So we have our 6 parts. So this would be 1/6 of the pi right there. Okay. Let's get this eraser here. All right. So let's get back into what we're doing here. So just like with the degrees, how the degrees go 30, 45, 60. When we go here, we're going to have pi/6. Then this will be pi/4. And then this one will be pi/3. So 30 degrees, 45 degrees, and 60 degrees, because they relate to those. As we continue, it goes the same order, 6, 4, 3. And then it's going to go in the reverse order over here. So this will be 2 pi over 3. This will be 3 pi over 4. And this will be 5 pi over 6, like that. So if you think about it right here, pi over 6, one more of them would be 2 pi over 6, right? 2 pi over 6, which is the same thing as 2/3, or pi over 3. Then this is the same thing as 3 pi over 6. This is the same thing as 4 pi over 6, and then 5 pi over 6 there, and then all the way around. So we're just kind of reducing these fractions to make it easier for us. Okay, if we keep going in pi over 6, then this would be 7 pi over 6. This next one right here would be 8 pi over 6, 9 pi over 6, 10, 11, and then all the way around. So since it's split right down the middle, we know that this has to do with pi over 4. This is 4 pi over 4 at pi, so this is going to be 5 pi over 4. This one right here, again, 6, 4, so this has to be a 3. This is going to be 4 pi over 3. And now you go the other direction, 3, 4, 6. So this is going to be 5 pi over 3. This is going to be 7 pi over 4. And then this is going to be 11 pi over 6. And we'll be able to talk a little bit more about that as we go. So this is going to be our radian unit circle. We will be using this as we go forward. So getting into sine, cosine, and tangent, in the last unit we were drawing it out. So I would give you like the sine of 60, and you would draw your coordinate grid, you draw 60 and do all that stuff. This is going to be similar, but we're not going to quite have to work as hard. What we need to see is that our x value has to do with cosine, and then our y value has to do with sine. We kind of talked about this briefly, but I'll break this down more in just a second. And then the last one is tangent. Tangent is going to be your y divided by your x. And the reason that this is if we have a right triangle right here, and this is a right angle, this is theta down here in the corner. We have a 1 here. We'll label this x and this one y. If you take the sine, right, sine is opposite over hypotenuse. So the opposite side would be y over 1, which is just y. So when we were looking for sine, we got y. And then when we are doing cosine, so that's adjacent over hypotenuse, well, the adjacent side is x over 1, which just turns out to be x. So if a problem is asking for the cosine, what you're looking for is the x value. And if it's asking for the sine, you're looking for the y value. Okay. The last thing before we flip it over here is if you think about a coordinate grid and where numbers are positive, if you think of this like a normal coordinate grid, if I go to the right, all my x values are positive, and if I go up, all my y values. So any coordinate point up in this quadrant is going to be a positive and a positive. Sorry, I don't know why I wrote x. Let's change that. It's going to be a positive and a positive. If we go to the left, then our x's are going to be negative, but if we go up, it'll be a positive y. So our coordinate point will look something like that. Down here, a negative x and a negative y. For example, like -2, -6, that point would be down here. And then over here, a positive x, but a negative y, like that. So what you're going to see is that there are not too many different numbers involved in our coordinates, but the negatives and the positives are going to be the main thing that are changing, and they might change between the x and the y. Okay, let's slide over here where we have a bigger circle to work with. It wants us to label the coordinates. So we're going to do this part right here where it says label the coordinates. We're going to do that back here. All right, so let's see, this first one, this first angle, let's do it in black. This is going to be 30 degrees. So how do I figure out what the coordinate point is here? Right, I want an xy coordinate. Well, the way I'm going to do it is using special right triangles. So that's 30, this is 60, and now I have my 90-degree angle there. So if this is 30, across from it is 1/2. And then this value right here would be the square root of 3 over 2. Well, our x value was root 3 over 2. And our y value to go up to this point was 1/2. So that is how we get our point, root 3 over 2, comma, 1/2, right? So if we erase this to make space for our next point, let's do it in red, right? This angle right here is a 45-degree angle. So if I draw a triangle straight down, I got my right angle 45 here, 45 there. Well, across from my 45s in a right triangle is the square root of 2 over 2 on both of them. So my coordinate point, my x, would be how much I go to the right or left. So that's the square root of 2 over 2. And then my y value is square root of 2 over 2 because I just went up that much. All right, so now I got those two, 45 and 30. And then to get my last one in this quadrant, let's do it in blue, right? We know that this last angle right here is 60 degrees because we did that on the front. So this is the first point is 30, second point is 45, this point is 60. So if we draw our reference triangle here, across from the 60 is root 3 over 2. Across from our 30 degree down here would be 1/2. So our coordinate point would be 1/2, comma, because our 1/2 is our x value. And then the other one is root 3 over 2, like that. Because this is our height, so the height is our y, and the bottom part is our x value. Just like if we were doing a normal coordinate point. If I had a point up here, let's say, for example, we went over 2 and up 3, then I would write this as 2, 3. It's very similar here, except for using the unit circle. So we're going to have our special right triangle properties right here. Okay, so what you're going to see as we go around doing this is that they are very similar as you go all the way around. All right, so let's take a look at this next one right over here. Let's work over here on the left. This point right here is 150 degrees. So this angle right here is 30. So if I draw my line straight down right here, now I have a 30, 60, 90 triangle, just like we did on the other side. And so across from this would be 1/2. Across from the 60 is the square root of 3 over 2, and our hypotenuse is 1. But we're not worried about that. When we're writing our coordinate point in, our x value, since we went to the left here, this is going to be negative. So we'd have a negative root 3 over 2. And then our height, our y, would be 1/2. So you can see, if you look at this point over here and this point over here, they're the exact same, root 3 over 2 comma 1/2, root 3 over 2 comma 1/2, except for this one is negative because we're in the second quadrant over here to the left. Okay, so you can see that the x and the y are almost the exact same, except for the negatives are different. All right. Using what we know about this, we can find our next point. So if we do our middle point here, let's do it in red like we did over here. This reference triangle right here, if I draw a line straight down, this is going to be, the middle is 45 degrees. This is 45 because this is 180, and this would be 135 here. So our reference angle would be 45. Okay, but we don't need to know that. So now that we have this, across from the 45, root 2 over 2, this is 1, this is root 2 over 2, and since we went to the left from the origin, this would be negative. So when we're writing our coordinate point, our x is negative root 2 over 2, comma, root 2 over 2, like that. And you can see from over here what we have going on here and what we have going on over here. It's the exact same, except for our x value is positive. All right. Or x value positive in quadrant 1. All right, last one here in blue. You're gonna see it's the exact same. So when we draw our reference triangle like this is a 60-degree angle because it's the biggest angle, and then this is 30. So across from the 60 is the square root 3 over 2. This would be 1/2, and it'd be negative because we're going to the left. So our x value is negative 1/2, and our y value would be positive root 3 over 2. So if you look at this one here and this one here, this one's negative, this one's positive, but it's the exact same coordinate points. All right. And so this is always going to be the case. Your angles or your coordinate points are either going to be, you have a couple of different options. It can be 1/2, it can be root 3 over 2, or it can be root 2 over 2. Those are the only possible things that it can be. Now, it can either be positive or negative, which adds some more combinations. But this is pretty much all we're dealing with right now, is these points right here. All right. So if we go all the way around our triangle, this would be 30 degrees. We draw a line straight down across from the 30, negative 1/2. Across from our 60, this way would be negative root 3 over 2. So when you're writing this coordinate point down here, your x is negative root 3 over 2, and then your y would be negative 1/2. All right. And we could actually finish up this one over here. This is 30. Draw this down. So our y value would be negative because we're going down. And then our x value right here would be positive root 3 over 2. So when we write this, it'd be positive root 3 over 2, comma, negative 1/2 would be our coordinate point there. So now that's all our 30-degree angles. We can get into the 45 and 60. We'll do the 45 first. So the middle point right here we said is 45 degrees. So if we draw our line straight down, right angle, 45 goes there and there. So our hypotenuse 1 doesn't really matter right now. So this angle right here, or this side, we went to the left, so negative root 2 over 2. And then we went down, so negative root 2 over 2 there. Right, so our coordinate point would be negative root 2 over 2, comma, root 2 over 2. And if you look back at all the times that we used the red, which was for 45-degree angles, it is always root 2 over 2, comma, root 2 over 2, right? Same thing everywhere in red. The only difference, this should be negative, is the negatives and the positives. So the first one, they were both positive. Then our x was negative because we went to the left, but our y was positive because we went up. But now we're going left and we went down. So then they're both going to be negative there. That's where we're getting that. So our last one is right here. This angle would be 60. So when I draw my line straight down, we got negative 1/2 here, negative root 3 over 2 right here. So our x would be negative 1/2, and our y would be negative root 3 over 2. So the hope is that as you continue to do these over and over, you can kind of memorize what the circle looks like, and then you're going to be able to do this a lot quicker than before. So this last part over here, we already did the 30. Let's do the 45. That's going to be this right here is 45 degrees. So if we draw our triangle, 45, 45. So we know that this x is positive because we went to the right, but our y is going to be negative. So when we write this point in, a positive x, so positive root 2 over 2, then our negative y value, like that. And lastly, we have this 60-degree angle right here. Angle. This is going to be 1/2 across from the 30, across from the 60 is root 3 over 2. And this is going to be negative because it's going down. So our x is positive 1/2. Our y is negative root 3 over 2, like that. And so now we have everything labeled. We drew a triangle for every single one of these. I just didn't leave them up because it would have kind of gotten messy. So what I suggest for you is to pause it at the individual triangles if you're a little confused on how we got it. But for all of these, every single one, I would just drop a line straight down. I know that this first angle is 30, so I put it there. And then I'm just going to label my triangle like I was in our last unit. And that's how I'm finding these coordinate points, okay? Something that's really going to help you when you're doing this because your homework, I believe, is labeling your full reference triangle, is understanding the connections between these right here. So what this is saying is that a 30-degree angle is the same as pi over 6, 45 is the same as pi over 4, and then 60 is the same as pi over 3. Okay, we will talk about these tomorrow. The quadrantal angles is what we call those, but we will touch on those tomorrow. As for now, you're going to get a blank unit circle. You're going to label all the degrees, right? Remember, they go like 30, 45, 60 all the way around. You're going to label all the radians, and then you're going to label all your coordinate points as well. All right. When I'm back tomorrow, we'll talk much more about this.